Hello YouTubers, welcome to part 2 of TamiyaTruckBuilding. Thank you to those who have sent messages of encouragement for this video series. In this part 2 I will be talking about my build options, organising the parts and getting started with the Volvo FH12 build. The good news is you'll be seeing more of this today and less of this. Firstly then, I need to decide what additional parts, if any, I wish to fit to the FH12. I purchased this kit with a view to it being a working model. I wanted to use it to tow behind my tow truck. Whilst it's impractical to try and use it as a static model, I have no plans to spend a lot of money on it. You might say it's a bare bones operational RC model. As a standalone RC truck, it will be an ideal build for the budget conscious or the beginner. So if you're looking at your first build and don't want to break the bank and also want to keep things simple, this build is right up your street. I'll be fitting 2 servos. The first, a 3 kg servo for the gearbox. The gear change shaft doesn't require a lot of force, so you can use a small power servo. For the steering, I'm fitting a 9 kg. I found through experience that these heavyweight models need some oomph to turn the steering. As a budget build for speed control, I'm going to fit a standard electronic speed controller. The 5th wheel will be manually operated, so no servo required there. As for battery, you could use a 2000 mAh without problem, but I prefer to use something around 4000, which lasts longer between charges. For radio control, I'm using my trusty Spectrum DX6C transmitter, which is paired with a Spectrum AR620 receiver. This is a mid-range 6-channel product, but again you can use a 4-channel without problem, and there are cheaper models out there that will do the job. In the illustration that I'm going to put up in a minute, I've included the price of a good budget TXRX for you to consider. Paint wise, I've decided on all over colour, cobalt blue. No, it's not a Tamiya colour. I generally use Halford's acrylic paints. They are excellent and a lot better value than Tamiya. Sorry Tamiya. Here's a rough guide for what it's cost to date. All in then, this has cost me around £400. Prices can vary wildly from day to day, so keep checking before you buy and you hit that buy button. I've been asked for a list of model suppliers that I have used, and that's coming up next on the screen. Please note I'm not affiliated nor sponsored by any of these companies, and the list is a guide only. There are many more suppliers if you search the net. Okay, so I have my extra parts. Let's get going with the build. In this open box view, I've taken out the nuts and bolts and put them into labelled containers, and I'm left with the plastic cards or sprues, which can be identified by a letter moulded into the plastic and by comparing the parts to the pictures in the back of the manual. Here's a Colin tip: label the bags, so it's easy to find a sprue when you need to. It sure saves a lot of hassle. Here's the first page of the build, there's stage 1. But before we do stage 1, there's a picture of a basic RC setup. We'll be doing this first to ensure all the parts work okay and to centre the servos ready for their cams or the horns on the top to be fitted in the right position. Okay, so here are the parts then for the test. we have my DX6E Spectrum transmitter and the AR620 receiver. This one doesn't have an aerial on it, that's what I like, it's actually built into the unit. I've already paired these two together so that they can talk to each other, which is quite a simple process. I have the battery, which will obviously go into the truck eventually, but that will provide the power for all of the receive side. This is the electronic speed controller, ESC. This one's an M-Tronics Viper Eco 27. Obviously once I've wired it up, I'll show you how the wiring goes. Two servos, more powerful one, the CS9, the 9 kilogram, which is going to go on the steering, and then the CS3 is going on the gear change. And we have a motor. So I'm going to wire all that up now, and then we'll talk about it. So, we have everything wired up. I'll just talk through the wiring first off. Battery. Polarity is important. I tend to mark the connectors so that I get it right, but don't worry, the two pins within here will only go in one way round, so you get the correct polarity going into the speed controller. The speed controller provides power to the receiver, which goes into number 1 on the receiver. The servo wires have 3 wires. They are either black, red and white, which is black is negative, red is positive and white is your signal wire or your control wire. Or you can have these here where brown is the negative, red is the positive and the yellowy orange coloured wire is the signal wire. There is a correct way around to put them within your receiver, and that depends on the particular receiver you're using, but the information will be in that receiver's manual telling you which way around to do it. You will also assign them to a particular port when they're fitted to the model. At the moment I've just put them into numbers 3 and 4 just so that I can demonstrate that it actually works. So we have power into the receiver. The receiver is lit up and is connected to the transmitter. The outputs, there are 2 outputs from it at the moment, which is this one and this one. The motor output comes off this unit here. So let's just look at the servos first. The power comes into here, it goes into the receiver, so the receiver is now powered. When you move the controls over there, these 2 wires here will control these 2 servos, which I'll just demonstrate now. As you can see, the one servo is moving. That would in fact be a gear change. And that can be assigned to either of these sticks or even a switch. So at the moment it's just working off this particular stick here. It's just to demonstrate that it works, nothing more, as you can see. And what that's doing is showing that it is centred, and that's where we want to leave it. This one here, the CS9, is coming off this one, as you can see. So both of the servos are working absolutely fine. The motor comes off this control unit, so you've got the power coming in. This will tell the controller how much power you want to apply or how much voltage you want to apply to the motor, and the motor will work accordingly. At the moment it's working on the axis of this one here. As you can see, there's nice control over the motor there. Look, you can actually get it running nice and slow. I've just left a bit of plastic on the end of the motor so you can see the spindle running. And then to go the other way, it runs in reverse. There isn't a polarity as such on the motor. What you can do when you put the model together, if it moves in the wrong direction for you, you can swap these 2 cables round, or you can even assign within the transmitter to turn this round, so if that's going reverse instead of forward for you, it can be swapped to the other way around. The only other thing I haven't mentioned on here is this little switch. This little switch just turns it off. Now there is no connection between them. I switch that back on, it's come back on again. Right, what I'm going to do now is assemble the steering servo, which is part 1. Note part 1 covers off both the steering servo and the shift servo. That's the shift servo, which I've marked up as gearbox, and this is the steering servo, which I marked up clearly as steering, because they are slightly different. Something to note is that the screws that are listed here for these servos are for servos that have plastic tops, and they have self-tapping screws that go into them. The CS9, being a metal geared servo, has a metal top, and it has a thread for a 3mm screw. So I'm substituting a 3mm self-tapper for a 3mm threaded screw, just to show you. Just get it to go in, do it by hand. There we go. As you can see, that's actually got a thread in it, so we will be using that one. Now, depending which servo make you have, Sanwa, Acoms, Futaba, Tamiya, they may have different horns on the top. These parts are called horns. Now there's 2 here. The only parts that I've taken off the sprue at the moment are the bits for the steering servo. That's what we're working on. I'm not working on the shift servo at the moment. So I've got 2 here, and I need to find out which one of them fits. Well, that doesn't fit. It's too tight. That one drops straight on. I'll show you that. That fits. There's a diagram here from the top which shows you where it should be fitted. Now, there are 3 parts to the steering horn. There's this bottom part, there's this part which is called the servo saver, which is a split ring. The idea of that is that if you overload the servo and it can't steer more than it wants to, it'll snap that ring rather than damage the servo. And the 3rd part here is this part that goes on the top, which has got a slot in the back which marries with that. Then there is a little ring that goes in there, like so. We know the servo is in the 50% position. I'm holding the servo as per the diagram, and it will fit like that, as near as 90 degrees as is possible. Alright? You could assemble the little ball joint on the front first before you put it on, so we're going to go ahead and do that now. Now, this particular one has the MA16, which is the bigger one of the 2, and it goes in, if you look at the diagram, from the front, like so, and it has the black nut on the back, like so. Now, to do this up, we can use the supplied Tamiya, which is not in front of me. I'll just grab it off my little workstation. This item here, which is very, very useful. The nut at the back is captive, so if we put that on there, we can do that up until it's tight. Don't over tighten things, you don't need to. It's worth looking and making sure it doesn't say that it needs to have thread lock or anything like that. This particular item doesn't. So I'm just going to place that on there where it needs to go. When you come to setting this up on the truck, you may have to just take that off and move it one cog or another. But the main thing is we've sort of picked the middle ground. I can put this screw in the top now, pick up my big screwdriver, my JIS screwdriver, and we can screw it down. These screws go down quite a way. And if you hold that, it down until it goes tight. What you've got now is a servo that works backwards and forwards. Compare that to your picture here, which is what you've got. You'll note that that is on the front, the screw is on the back. It's always worth checking what you've put together. That is your steering servo completed. The next one we're going to do now is the shift servo. That was just one we used to centre it. Here's our shift servo. Let's just check that we have more or less got it where it's supposed to be. So we can just move this roughly so that it's where it should be. That's one. And that's one. So that's near enough halfway point on the servo. This one takes the 2.6mm size screw. Now it might be that one or that one. Judging by the amount of plastic parts that we've got to put together here to go on the top of it, there's a good chance it's going to be the large size one. So these are sprues E again. So you've got E1. Here's my flat sided pliers. What we need to do first is take off the parts that we need. That's the servo saver. Again, there's a choice between E4 and E12. So we look and find there's E4. So we take 4 off the sprue. Like so. We'll use a knife to just trim that little bit off the end of there. And number 12, which is this one here. That's number 4 and number 12. So it's one of those two. We'll put the parts in here. I'm going to move that one out of the way so it doesn't confuse us. That was the alternative one for the first servo. Now we also need for here E7. And the pictures are very, very good, so you can see which part is E7. You can see that it's a piece that's circular with teeth on it, which is what that one is there. So we're going to go for E7. This is where these flat-sided pliers come in beautifully, because you can cut flush with the part. You rarely need to finish the parts off with a knife afterwards. We need E6, which is this part here. We'll drop that in there as well. And we need MA15, which is the small ball joint. We need another E2. There's the other E2 on the sprue there. That just goes underneath the screw on the top of the servo. Pop that in there. So we should have everything we want now. E2, E6, E7, E1 and 4 or 12. The screws we've got, and we've got the little ball joint and the 2mm nut. So we've got everything that we need to build the shift servo now. So that can be put to a side. I'm just going to trim off this one part while I've got the chance. You may do this on a working mat or on some other firm surface. I'm just being lazy and just doing it on the corner of the book. So we've got that done. Now you'll note with this one that when you finish it, it finishes with the little ball knuckle facing in parallel with the length of the servo, not at 90 degrees like it was with the steering one. Shift servo, gearbox, so we've got the right one. Now we need to find out which fits, the E4 or the E12, so it's one of these two. That would go on with a hard push, whereas that one drops into place. That's a nice snug fit, which is how it should be. So we just pull that back off again for the moment. So we know it's this particular one, not that one. Let's assemble it. We need to put the steering servo onto it. Sorry, servo saver onto it. We then have to put on E7. Now this has got a notch on the back of it, which will fit into that gap there. So those two parts would actually pull apart. They're only held together by the servo saver ring, that big C-clip in the middle. So as you can appreciate, if too much pressure was put on it and it couldn't turn it, it would snap the ring rather than damage the servo. That's why it's called a servo saver. What we've got to do now is put this item onto here. Now, this is quite interesting. Note the way it goes round. The diagrams are very, very good. If you look, that can be fitted in various hole positions. That allows the swing of it to be increased by moving it either closer to the spindle or further away. If you look at the diagram on the left, the correct position that they're suggesting is it goes in the outer hole, or the outer notch I should say, which is there. On top of that will be this, which will help to hold it in place. So that's going to be the complete unit. Now before we put that together, I'm going to put the knuckle on because it's easier to do rather than when it's done together. So we've got it like that. We put that in there. Just keep all the parts together. You've got a 2mm one that goes on the back. Useful to have magnetic screwdrivers, as you can see, because you can pick up these parts. Pop the little 2mm screw flat nut in the back, and just start to do it up. One of these has got a 2mm on it, there you go. And again we just turn that and pinch it up tight, nice and tight. Just check we got it the right way round, which we have. That is now going to go on there in line, near enough in line, see, with that. Now because of the depth that we've got to go down there, I suspect we need to use the bigger screw. And as you can see, the screw drops in that far and then the balance of it will thread in. So we'll try again with a bigger screwdriver. And that won't go in. Let's just check that thread again. That screwdriver is too big for this little small screw. That's definitely 2.6. But here's an interesting one. Is this 2.6 or is this bigger? Because it seems difficult to get it to go into the hole. It is 2.6. So perhaps I just need to press on a little bit firmer to get it to go in. Let's get that back where it needs to go. Pop that on there. Pop that in there. Let's try again. Yeah, there we go. I just wasn't trying hard enough. It's always best to be certain rather than damage these things. So there you go. That's fitted now and solid, as you can see, and in position, lined up with that. That completes stage one, and the other 3 screws there are just now spares. So you've probably got a separate tin or something. I've got a separate tin. I'll just put the spare screws in too. That's completed part 1. Well, that's it for this episode, YouTubers. I hope you found it interesting. In part 3 we'll be straight back into the build. Any questions, please send me a message, and if you like my video, please hit the like button and subscribe to my channel. Bye for now.